So lessons 1.4 and 1.5 have been combined, and they're all about linear equations and some applications. Lesson 1.4 begins by reviewing slope of a line. So we'll just write down a few things about slope. You guys know that slope is the rise over the run. Slope can be what we call the change in y over the change in x. The little triangle is the Greek letter delta, so it just means change. The equation for slope, we use the letter m. It is y of 2 minus y of 1 over x of 2 minus x of 1. And in order to find slope, you have to have 2 points on a line. Slope can be positive, so the line would be going uphill from left to right. It can be negative, so the line would be going downhill from left to right. It can be 0, that would be for a horizontal line, or it can be undefined, and that's for the slope of a vertical line. We're going to begin here by finding the slope of each pair of points. So again, I'll be using this formula, y of 2 minus y of 1 over x of 2 minus x of 1. And this should be a review for you guys. You would have done this concept in Algebra 1 in high school. So we'll take our second y minus our first y over our second x minus our first x. That will give us negative 1 plus 3 over negative 7. And that's a slope of negative 2 over 7. And I see now I skipped a step. Some of you might appreciate me writing 2 over negative 7, which is negative 2 over 7. Okay, if I go and do the next one, I'll have 6 minus 2 over negative 3 minus negative 3. That is 4 over 0, which is what we consider undefined. You can't divide by 0. Dividing by 0 results in an error message on your calculator, so we're going to write undefined. If we had to describe this line, it would be a vertical line. So if you go to actually graph these 2 points, they're going to fall in a vertical line, hence the slope is undefined. And if we do this last one, we'll have 2 minus 2 on the top, negative 4 minus negative 3 on the bottom. And that's 0 over negative 1, which is 0. 0 on the top is 0. And that would indicate that you have a horizontal line. All right, what is the error with this problem? So they were to find the slope, but they've made a mistake somewhere in their work. It looks like they did take their y's and subtract them. I don't see a mistake there. But the mistake is right here in the denominator. If you start by taking negative 1 and then subtracting 4, your y's need to be in the exact same order, or your x's need to be in the exact same order. So you need negative 3 take away negative 2. If your order is backwards, that results in a sign error for your slope. So our slope should actually be negative 5 over negative 1, which is a positive 5. All right, writing the equation of a line. This next topic is also something you would have done in Algebra 1. We have slope-intercept form. M is the slope, we already talked about that. B is the y-intercept. Where does the line cross the y-axis? So if I were doing this problem here, I could write the equation of my line by making my slope triangle. So I'm going to find m by counting the rise. That's the distance between 6 and negative 3, which is 9, over my run, which is 6 spaces. My line is going downhill, so negative 9 over 6. divide by 3. My y-intercept is going to be right here at 3. So my b is 3. And then y equals mx plus b. I plug my slope in here, my b in here, and I have the equation of my line. We also have point slope form. It's handy when you're given 2 points. And this equation, or this example here, is going to illustrate how to use point slope. To find a point slope or slope-intercept form given to ordered pairs, you're going to have to find your slope first. So we subtract our y's over our x's. So -7 take away 8 over -5 take away -2. So -15 over -3, which is +5. Then we go to point slope. And I'm just going to let this first ordered pair be my x of 1, y of 1. All right, I could choose either ordered pair, but I'm going to stick with the first one. All right, so y stays y. Y of 1 is 8 from our ordered pair. Our slope is 5. X stays x, minus x of 1 is -2. I'm going to clean that up just a little bit. And there's our equation in what we call point slope. So if you're asked for point slope, you can leave it this way. To write it in slope-intercept form, part B, we're just going to take that equation and solve it for y. Add 8 over, and we have that equation right there. Okay, we've already talked a little bit about horizontal versus vertical lines. Just remember that the horizontal lines have a slope of 0. A vertical line will have a slope of undefined. Okay. If you want to graph a horizontal line, say of y equals 3, that indicates that my line is crossing the y-axis at 3. So this would be y equals 3. If you want to graph a vertical line, it will have the equation x equals a number, so let's say x equals -2. Then you will be crossing the x-axis here at -2. So there is x equals -2. For this part of the lesson, you'll be graphing lines in slope-intercept form and then a horizontal and vertical line. What I would do is I want to get this equation in slope-intercept form first. So I'm going to rearrange things. I'm going to subtract 3x to both sides, so subtract it over. The 8 stays positive. And then I'm going to divide everybody by -2. And I'll have 3/2 x minus 4. To graph that, I will go down 4. That is my y-intercept. Then my slope is 3/2, so I'll go up 3 and run 2. So rise 3, run 2. I want to run to the right so that my line goes uphill because my line has a positive slope. So this is y equals 3/2 x minus 4. To graph y equals -2, I will cut the y-axis here at -2. And to graph x equals 5, I will find 5 on the x-axis and graph it. Okay. Slope can also be rate of change, and we'll see that with application functions. So if you're interested in the rate at which the number of adult males living alone has increased, you would be finding the slope for the males. So the rate of increase for males would just be the slope for the males. So we will take our y's and subtract, and then we will subtract our time on the bottom. 2013 minus 2000. All right, 15 minus 11.2. Let's just do that real quick. It's 3.8. We'll divide that by 13. Doing that on my calculator gives me about 0.29. So if I were describing this, I would have 0.29 million per year. So rates of change will have a label. So you'll have a label for the top numerator and for the denominator. So this was million males per year. So the number of U.S. males living alone, ages 18 and older, has increased by 0.29 million per year. Okay, we can also find rate of change for a line or for a curve, something that's not linear. And that line is called a secant line. So a secant line goes through a curve basically at 2 points. So if we were looking for the slope right here, we would identify 2 points on the curve, draw a line through those, and then find the slope for that line. That is called the slope of a secant line, and it's also referred to as the average rate of change of a function. So the formula is this right here. And you guys, that is no different than taking y of 2 minus y of 1 divided by x of 2 minus x of 1. F of x of 2 and f of x of 1 that I highlighted, those are actually y values. So it's just finding the slope. And I'll demonstrate that here with these two examples. All right, if I want to find the average rate of change, again, that is just code for finding the slope. Okay. Remember, the numerator is f of x of 2, and then subtract f of x of 1. So x of 2 is 3. I need to know f of 3 first. So I'll plug 3 into my function right here. I have 3 cubed minus 2. So 27 minus 2 is 25. I'll also need to know f of x of 1. So f of negative 2. Plug in negative 2. And that's negative 8 minus 2, which is negative 10. All right, so then the average rate of change is f of x of 2, so f of 3, minus f of negative 2, divided by, and then we subtract our x's on the bottom in the same order. So 3 take away negative 2. So again, I've plugged everything into this formula right here. And that's 35 over 5. So my average rate of change is 7. And we'll try that again right here. Okay, I need f of x of 2, which is 64. And then I need f of 9, which is f of x of 1. The square root of 64 plus 2, using this function right here, is 8 plus 2, which is 10. And then for 9, it will be 3 plus 2, which is 5. Average rate of change is, and then it's y of 2, so 10, take away 5, and then I put my x's in the same order, so 64 minus 9. So we have 5 over 64 minus 9 is what, 55? 1 over 11. Okay. We'll also look at a few linear models. So when you start getting into linear models and the average rate of change, you're starting to cover the material in less than 1.5. Okay, the first one. A cell phone plan costs $120 per month for 4 lines. Each additional line is $24.99 a month. So we're going to write a linear function for that. So we're going to do maybe c of x for a cost function. So that replaces y. It's $120 set a month for 4 lines. So we're going to do $24.99. All right. Let's see here. And then let's do x minus 4. Oh, does that make sense? Let's just do, each additional line is $24.99 a month. Okay, so I think we actually need to maybe make this into a piecewise function. Let's do, and we haven't studied those yet, so let me think for a second. I gotta remember, I don't have my answer key in front of me today because it's at work. So let's just do this. Okay, yeah, let's keep it this way. We'll make it simple, $24.99 x plus 120. All right, so what is c of 2? C of 2 would be plugging in 2 right there. And let's go ahead and run that in our calculator. I stumbled a little bit because there's so many different ways to set this up, and I want to give you guys the simplest way to do it. So $24.99 times 2 plus 120 is $169.98. All right, what does that mean? So if I'm plugging in 2, that means I'm plugging in 2 for x, and that means I have 2 additional lines. So this is the cost for 2 additional lines. So this is what you're going to pay for 1 month of service for 2 additional lines. So basically you have 6 lines altogether. Okay, this next one is a blood pressure problem. So we have age going along the x-axis, blood pressure going along the y, and it's your systolic blood pressure. So they're telling you that here in part A, it says use the 2 points shown to write a linear model relating y as a function of x. So when they want a linear model, they want you to write slope-intercept form for those 2 points. So let's go ahead and do that. The first thing you need to do is find your slope. So we're going to take our y's and subtract them, and then our x's and subtract them. 130 minus 118 is 12. 51 minus 21 is 30. Okay, 12 divided by 30. For these problems, getting a decimal is perfectly fine, is 0.4. All right, I'm going to go to point slope. I will plug in the first y value, so 118, and that's from this ordered pair here, equals my slope times x minus 21. Keep working here. I'm going to distribute. Let's see, that's going to be 8.4, I believe. Okay, I'm going to add 118 over to that. Okay, part B. Interpret the meaning of the slope. All right, our slope was 0.4. I'm going to write that over 1. Okay, when you find slope, it's the y's that are on top. The y's are measuring millimeters of mercury, and then age is on the bottom. So how would I interpret that? As for each year of age, your systolic blood pressure rises by 0.4 millimeters of hydrogen. All right. Part C. Use the model to estimate the systolic blood pressure for a 55-year-old. All right, remember X is their age, so we're just going to be plugging in 55 for X. And that is 131.6. Okay, and that is the end of these notes. Please make sure you take them down, try the homework, and then if we have time on Wednesday, I'll try to answer questions. If not, you can always shoot me an email or pop in during my student support hours this week, and I'll get you squared away. Thanks.